Hi everyone, welcome back. We'll continue working on our dungeon crawler. So what we had was this sort of map with all the default lighting, and where we left off we wanted to use a different ambient light. We now have a completely black color, and we were working on adding this resource to our lighting, and I had to quickly look it up, but you need to do lighting.resource, and now should be able to see the effects of the new lighting, which is now completely black as we used a black ambient light. What if we want to see something? Well, we can of course add a light to our camera. For instance, not a spotlight, an omni-light, I believe it's called. What kind of a point light? We need a point light. That will sort of represent our torch. And then we will take our camera anchor and add the light entity as a child. So we should now at least have again some light. Okay, so we have some light from emitting from around our camera. The problem with using only this point light and absolutely no ambient light is just that you get a very harsh environment. So what we will do is we'll go back to Pixelmator and make sure that the ambient light is just a bit less dark, and we could, if we want, use a slightly warmer color. I will use torches to give a warmer color. We'll actually use a slightly colder color, so a very dark blue. Let's see what this does. I don't have a really easy... Oh, I think I forgot to fill using this new... let's see, effects. Yeah, I should fill with the new color that we chose. So it's a bit dark blue grayish. We again have our ambient light. And now we have this one. We should replace it. Yeah, I was afraid it would just create a second one, but that's not a big problem. So let's see what this looks like. Probably we'll see a bigger difference if we don't add the point light. So there's now at least a bit of ambient light, so you can at least see something. Okay, I think I like this fine for now. What I would like to do is able to control our camera, and we'll start by just stepping forward and backwards in our world. So we want to start a movement. So to do that, let's create at least a couple of buttons we can press. We create a Z stack, and this will take an H stack. We'll create a V stack, and it will have a button called move forward. And we will use one that says let's go back. So let's see what this looks like. So we have our buttons, and now we need to hook them up into our world some way or the other. So how can we do that? Well, one way is we need to of course take somewhere keep a track of all the position of our player, So let's create a new file. I'll call this the world. And this will have one property for now, the player position. And for now this will be a simd. So we have access to simd3 float. And we can set it to 0, so it's at the 0 position. And we can create a function called move forward. That takes our player position. And we'll do -1 because the camera is still back, looking backwards. We can fix this at a later time. And we'll move back. And do the exact opposite. And of course we can create a world here in our content view. And then instead of doing this, we can say world move forward, world.move back. And we can say new player position and see if we're able to influence the player position. So we move forward, new positions, and we can go backwards, and that's it. And of course, we don't see any difference just yet, because we're never updating our camera position. So this needs a bit of work, because we somehow need to update our view and especially the camera position in it. Well, we have this update NSView. Unfortunately, we can't use that for this, because this gets called more or less when you recreate the game view. This is not the game's update loop. To get an update loop, we need to have a system. And for that, I'll create a new file. We'll call this a world update system. And this will be a class. And this will be a system. And this requires RealityKit. This then requires some protocols. Let's take a quick example. I think that's slightly easier. So let's go back into our RealityKit, and we need systems. So I'll just use this very simple stub as an example of setting up our system. We'll need a component in a bit. This is our class. We don't need this query. What we do need in this system is we need to get a reference to the world. And you can't pass it in the initializer, because the way you register the system is when you create your view. You just register the system. Let's see, this is called world update system. So we need to get it from the scene when we at a later time. We can't pass it in as a property. We need to search for it. We can find a world by saying scene, find entity, and then we need one with a name. And we will, meaning that we need to tie the world into the scene somewhere. So for now we'll say we'll have a world entity, and the world entity will have a component. Let's see how you get the specific component again. Okay, we'll do that in a bit. We need a world component to hold a reference to our world, and this one just has a reference to the world. And then we can go into our game view, where we set up our view. We can create a world entity that has a world component, and this requires a world, and the world needs to be passed in, meaning we can do that, get a reference here if we add it as a property here. So we need to have a world entity, then we need a world anchor. It can be at 0, 0, it doesn't really matter where it is. We take our world anchor and we add the world entity as a child. And we take our scene. We add the world anchor. And we need to make sure that our world entity has a name we can search for. So we're tying them together based on name, which is not perfect, but that's more or less the way this works. So we now have a world entity, which could be an entity. So let's make sure that we have one, and if we don't, we'll send out a message. So now we have our world entity unwrapped. We need to get the specific components, and that requires a bit of thinking. Let's see, the not events, we need entities. Oh, here it is. So this should be a world component. So we create a fatal error. No world component found on world entity. Now we have a world component, and now we can set our world to the world. So now we tied the world and the world component together, and in the update we can say print, for instance, print updating world at we don't need that date. We'll just say updating world. So we can run this. Let's see, we need to now pass in the world when we create our Swift UI view. And we run. And we can see that the world is updating. Let's clear it and it fills again. So we have our update loop running. Our system also needs a link to the camera. And we more or less need to do the same thing again, but this time we need a camera entity. We actually need the camera anchor. And then we can set camera transform to the camera anchor transform. We might even just store a reference to the camera anchor. This is now an entity. Let's see, how can I get its anchor? We should just use an entity. So this should be an anchor entity. And this is the camera anchor. And now we need to make sure in our game view that where we're creating our camera anchor, so again we're using strings to tie them together. Okay, we have a camera anchor, but we're not using it yet. Now what we'll do is we'll say our camera anchor dot position. Position is our world dot player position. Let's see if this works. And now we can move forward and we can move backwards. And you can see the bounce of the floor and the ceiling. So we actually accomplished quite a bit, because we now have a way of tying what is happening in our world, and this is code, model code, that we will use test driven development to further improve and add logic to, and we tie that to a way of showing the results of that in our in our views. And I think that's quite important, because we don't have, for a bit, we will not touch that much of this view code. Of course, the position of the cubes, basically walls, will change over time, but we can start working on implementing more logic for our player next time. So we can look at moving sideways. We can look at rotating where the player is looking. It's a bit more complex, but yeah, I'd say this is a nice place to stop for now. Thanks for watching. Have a great day.